Welcome to the more moderate level challenge for 13. Today I'll be showcasing my workflow for creating the outside calipers, but before I get started I need to create a plan of attack first by abstracting the model into a set of guides that I can use to construct one of the arms. And then the idea is once I've got one of the arms done, I can then reuse that arm to create the whole model. So it'll become clearer as we get started. So let's start by taking a look at the picture that we're given. It looks like we've got a straight line here and another one here. It looks like we've got a curve and these two curves are the same. That curve is part of a circle, and then the diagram suggests that we've got from this point a pair of two other curves that go from that line. So that suggests we've got two different circles, one that creates the green curve and another one that creates the red curve. We can infer from the diagram that we've probably got a different curve up here as well, up to about this point, and then a different curve on the outside over here. So by looking at the diagram, it looks like we've got four different curves. I'm just guessing at this point, but we'll see if that works out when we come to building it in SolveSpace. Here's a different perspective of the outside caliper, and I've left the original picture at the top left corner there. And I know that I can join this fulcrum to this part using two straight lines. So I've tried to use this red circle to create an arc that goes from this vertical line down to the tip here, and then this green circle to create an arc that goes from the black line on the inside here to meet the red arc at this vertical line. These small circles represent the centers of those circles. Okay, using that same logic, I'm just eyeballing the circles and placing them where I feel is best. So let's carry on. Let's focus on the outside curve of the arm. This dark blue arc I created using a slightly larger circle. Well, I wasn't sure where to place the last circle to create the arc going from the outside line to meet the blue one. So the idea I have now is to use the plan that I've created, and then I'm hoping that it'll just come together as I'm building it. So I'm going to head into SolveSpace now and try and recreate this plan there. Let's recreate these guides. I'll select the line tool, click and drag from the origin and create a horizontal line. Select the line, click G on the keyboard to convert it into a guideline. And now select it again and click constraint distance. And I think I'll give it a length of 100 millimeters. Selecting the circle tool, I'll create a circle at both ends. Select both of them and click G on the keyboard, making them into guides. Selecting the smaller one now, giving it maybe a diameter of 10 millimeters and constraining the larger one to be, let's say, 70 millimeters. I don't want it to be too big. I'll select another circle now to draw the dark blue circle. Reduce its size as well to something like 80. So I'll select that circle and click G on the keyboard. I've constrained its diameter, but I've not constrained its position, so I'll do that now. So let's draw a line from the center of the new circle to the origin, convert it into a guideline, constrain the distance between these two lines by clicking constrain angle. It's currently 47 degrees. That means that I could use something like 45. So let's just start with what we have here. I'll select the arc tool. Now you see that the diameter hasn't been constrained, so I'll select it and constrain its diameter to be 10 millimeters. I'll draw a line going from here to here. I'm not going to drop it on this, and then I'll draw a couple more arcs as well over here. I want this contour, the center of this arc, to coincide with the origin. However, if I select them both and click constrain point on point, I will have a redundant constraint problem. The way around that I found is to select the semicircle origin here and the origin and just constrain them to be vertical to each other. And now you'll see that the contour coincides perfectly with the circle beneath it. I'm assuming that this point will be vertically aligned with the origin, so I'll select them both and click constraint to be vertical, and I'll leave this free for now. So let's do the same thing now for the outside arc. So I want the center of this arc to coincide with the center of the green circle. So I'll select them both and click constrain to be vertical, and then I'll constrain these two lines to be vertically aligned and these 2 points to be horizontally aligned, just like that. So now we've still not constrained the distance of this point from the origin. So let's see what the distance of this line currently is. It's currently 4. Let's just go with 5. And over here, I can draw another arc just to join those 2 points together. But now I need to constrain the diameter of this arc. I'm not going to hard code the diameter. I'm going to make this diameter adjustable by constraining the center to be horizontally aligned with one of the outside points there by clicking this button, constrain to be horizontal. Now, if I click and drag this point, you see that the arc will change its diameter, but I can bring it down closer to here to touch this horizontal x-axis. And to do that, I'm going to select the point tool, click the point tool on the arc, constrain the new points to be vertically aligned with the center of the arc by clicking constrain to be vertical. And finally here, what I can do is select that point and constrain it to be horizontally aligned with the origin. It looks like these 2 points are a little bit further than what it looks like in the diagram, but I'm just going to leave it like that for now. Now we need another arc to bridge between these 2 points. In the plan, I had a circle that was down here somewhere, and if I draw the circle like this, you can begin to see that this may be correct. So I'll click on that circle, click G. I'll make the end of this line to be overlaid with this guide circle now by selecting the circle and the point and click constrain point on curve. And also I want this curve to be overlaid with this point. So select them both and click here again. So I'll constrain center of the circle and the origin to be vertically aligned with each other. And I can adjust the diameter of this. So what I'm going to do, I'm guessing that it would be nice, wouldn't it, if I could get the center of this circle to be halfway between the origin and maybe the bottom of this circle. So let's do that. I'll select the line segments tool, create 2 lines. So I'll select both of the lines, click G, select them again, and then click this button, constrain to be equal length. Now we've fully constrained this guide circle. Now if I select the arc tool again and go from this point to here, constrain the center of that arc to coincide with the center of that guide circle that we just created by selecting the 2 points and click constrain to be vertical, we'll have another error message. I'm not really sure for the reason for that, but what I know is that sometimes you just have to help SolveSpace a little bit. So I'll click and drag that point further down and then select them and click constrain to be vertical. Now it works. Now the next thing I want to do is position this line correctly along the new arc that we've just drawn. I want this point to be along this curve where the line is tangent to the curve. So let's do that. So I'll select this line and the new curve that we just drew and click constrain to be tangent. And now you'll see a little T symbol here saying that this point now is correctly positioned where this line is tangent to that curve. We need another line now to be tangent to another curve that comes out from here to here, but I'm not really sure where to put this yet. Now we need to create that last circle. Let's delete that arc for now. So I'm going to need a bigger circle to connect these 2 points together. To have a bigger circle, the center is going to be further down. So let's see what happens if I select this point and click outwards. It looks like that could work. So I'm going to select the circle, convert it into a guide. The position is currently constrained to this point here, but I need the diameter to be constrained such that this point will be overlaid on top of it. So I'll select the point and the circle and click constrain point on curve. This point be constrained onto that circle in the same way, clicking constrain point on curve. And then I'll complete the contour and I'll drag this down. I want this arc's center to coincide with that point. Select them both and click constrain to be vertical. We've got 1 more degree of freedom, and that's because we need to constrain this line to be tangent to that curve. I'll select them both and click constrain to be tangent. So far so good, but if you look closely at the fulcrum, these 2 lines are almost parallel, whereas in the image the distances between these 2 lines need to be broader. So let's fix that now. I've deleted the constraints that were at these points. Now I'll delete the arc. I'll just change the radius of that now to something like 20 millimeters and then constrain this point on the guide circle by selecting them both and clicking constrain point on curve. Do the same thing on the other side. Now let's redraw the arc. And I'll constrain the diameter of the arc to be 20 millimeters as well. The next thing I want to do is constrain this line to be tangents to the arc. I'll select them both and click constrain to be tangent. The same thing on the other side. If I hide the construction entities and the dimensions, it's kind of looking better now than it was. Let's go ahead and work with this. Let's extrude it by clicking here. So I'll select one of the extruded axes, click constrain distance, type 3. Middle click mouse button, you see it's got some depth to it now. And I'll save this as a SolveSpace file. I'll go to File, Save As, and I'll call it Caliper Arm. Click Save. Let's recreate the whole caliper arm by duplicating this. And to do that, if you remember from one of the previous videos, is to go to New Group, head down to Link Assemble, and then open up the same file. The next thing I want to do is just to rotate this imported model such that it's pointing the opposite way. And to do that is you hold down Shift, click on one of the points, and just drag until you have something close to what it should be if it was rotated by 180 degrees. And it's a bit tricky sometimes. To drag the model down, you let go of the Shift key, click on one of the points and just drag, and try and get it to be roughly what it would look like if it was orientated and positioned properly. Now I can constrain the orientation of these two models to be the same. These arrows sticking out here are normal lines that are local to the coordinates of the points in each model. So I'll select this normal line and the corresponding normal line on the other model at the fulcrum, and I'll click this button, constrain normals to have the same orientation, and then I'll select this point at the fulcrum and that point at the other fulcrum, constrain point on point, click W on the keyboard, and now it looks like we've got our finished model. I've not created a hole here for the bolts. I was just more interested in trying to recreate the actual caliper shape. Now I'll rotate and click on nearest isometric view. In the properties panel, click home. You'll notice we've got 0 degrees of freedom, hide all. It looks like we've got an outside caliper. The difference between mine and what was given is that this is above this one, whereas it's the opposite in the other one. So to summarize, I assumed from looking at the diagram that was given to us that the curvature of the arm was done using 4 different curves, and to try and reproduce that, I positioned these circles relative to each other. I don't know if outside calipers, if there's a special way of recreating them. For this, I made quite a few assumptions and kind of eyeballed a lot of it. So I hope you found it useful, and I'll see you in challenge 14.